Ladies and gentlemen, please welcome on stage our Master of Ceremony, John Acton.
Okay. You know what's great about an auditorium like this? When the lights go right down, you can see just how many people are still on their mobile phones. There's a hint there. Okay. This is the last session, the plenary 2 of the day. It's the last session between us and the cocktail reception networking event at 8 o'clock. So we'll try and keep to time. This session's all about warehouse. I'm going to move away from that. It feels a bit whistly. Is this working? Hello? Hello? Yeah, okay. So this is about warehouse management, and we've got a fantastic panel and keynote speaker, which I'll be introducing in a few seconds. There's no doubt about it that the keynote speaker represents a company that I think is blazing a trail on this, using robots in their warehousing solution. We're going to hear a lot about that, so that's fantastic. So I'd please like welcome on stage Mr. Stuart Mcguire from Ocado. Now, Stewart is Head of Corporate Development at Ocado UK. Great to see you. Now, before we start, Stewart, I'm going to ask you a few questions. You can get his bio on LinkedIn and in our site. No, you can't. No social media. No social media. Okay. Right, I've got a few questions for you to warm you up and relax everybody. So, if you could have a dinner party, right, and invite 4 people to that dinner party from anywhere in history or present day, who would you have?
Check. 4 people.
3 if you like.
3. You asked me this earlier. I said Alexander Hamilton, Kurt Cobain, and Jerry Seinfeld.
That's pretty cool.
Yeah.
You got everything covered there, haven't you? Right.
Yeah.
Okay, now, what's your favorite football team?
I support Birmingham City because, as you can probably tell, I was born in Birmingham.
Yeah, right.
It's true.
Okay.
I'm from Birmingham.
Okay. Any Birmingham City fans in the house? Didn't think so. Right. Okay. Right. Now, when you first passed your driving test,
Yeah.
What was the first car you drove?
My dad's Pontiac Parisienne, which was gigantic, and I was even smaller than I am now. So yeah.
God, I hate him already. Right.
Yeah.
Mine was a Mini 1000 H-Reg, 25 years old. Had a hole in the floor. Anyway, last question. What advice would you give to 16-year-old self?
Never hedge, I think, is good advice. I hedged for a lot of times, and it's difficult to do well if you don't go in with both feet.
That's sound advice. There's your
Okay, clicker.
Over to you.
Great. I'll try and keep this short. Thank you for that, and thank you for inviting me. It was a bit daunting, AI in logistics, and I'm a corporate development guy, so we'll see how this goes. I had to do a fair bit of research. I did find that it wasn't very easy to define. There's 3 things that I found that I think are worth pondering. Number 1 is artificial intelligence, real intelligence. An artificial pearl is a fake pearl, but a synthetic pearl is a real pearl. So maybe we're using the wrong word. Is it artificial intelligence we want, or is it synthetic intelligence? Secondly, does a little bit of cleverness become intelligence at scale? The example here I would use is an ant. An ant is not very smart, but a colony of ants is really quite smart. It can find food, can bridge things, it can communicate. And that's important because we have a robot that can move from there to there, which isn't particularly clever, but as a swarm of robots, it may very well be. And bear with me on this one. Can airplanes really fly? There's a number of ways to understand flying. One way is to look at the group of flying animals and analyze them and hypothesize that the structural elements of those animals are what allows them to fly. There's a wing, there's some feathers and some membrane, and they flap their wings. And you could say, well, if I put a membrane or feathers on me and flap my wings and jump off a bridge, can I fly? Obviously not. And then a researcher might say, well, you haven't got the feathers right, or you haven't got the membrane right. But obviously, that is not what we're looking for here. When we think about that, it's not relevant to look at the natural state of flying. It's more relevant to look at the principles, i.e. aerodynamics. And using the same argument, this is like chasing AI when we're trying to mimic humans. Like, it may very well be that when we ask the question, can computers think? It's like asking the question, can airplanes really fly? It's not that airplanes can't fly, they can. Maybe computers think in a different way that humans think. I did find a couple of definitions. I'm not going to read them out, again, trying to be expedient. The third definition is the one I like. It's what hasn't been done yet. It's typical, isn't it? So enough about that. I'll come back to all of this AI stuff at the end. I'm going to skip who is Ocado. Most of you know that we're an online grocery company that does a lot of technology. We used to build systems like this. And a lot of this is going to be very familiar with the people in this room. There's lots of linear conveyor belts. There are goods-to-man workstations. This was bespoke. It's not easy to scale. Basically, if you had a customer order, these totes would be rooting around in this warehouse. There's 32 kilometers of conveyors in our first warehouse, CFC, in Hatfield. And if you needed one item in that spur, the bin would have to go down and all the way back just to get that item. And it would stop, the bin would stop in front of a picker. And that picker would have to find the item. So it was a bit of a zone pick or a pick to light operation. So it wasn't particularly efficient. As I said, it was not easy to scale. And it's very difficult to sell that as a bespoke system, which was the business model that we were moving into. Then we started building systems like this, based on a hive. So the hive has virtually everything in it. It's got inventory. It's got customer orders. There's lots of systems that integrate with that hive. So the inbound decant, the machines that put the totes in the bins and take them out of the bins, the pick stations themselves. So this grid is a structural grid that the robots traverse over at the top. They can pick the top bin off the stack, and if they need a bin underneath, the two robots will go. One will take a bin off the top, and you'll grab the bin below that. There's some random access there, which is really useful, and you can send multiple robots to get multiple items. So a grocery basket might be 45 items. You could theoretically send 45 different robots and pick that within a few minutes. This is going to be a video. This is video. Actually, before it becomes a video, I'm going to describe what this is. This is a simulation, and simulations are critical in our business because you can't build a warehouse like this without knowing what it's going to do when you turn it on. So I'm going to describe what you see here, up here on the screen. First of all, there's the grid itself. The grayness indicates how deep the stack of bins is. So a very light gray cube or cell indicates that it's completely full. A very dark black square indicates that it's empty. And what you'll notice is that there's a channel through the middle of that system. And that is where the pick stations are underneath. So even though it looks like they're full, which they are, they're only one tote deep. The bots are on that grid, and they're different colors. The light blue bots are charging. The dark blue bots are doing inbound. The light green bots are doing bin retrieval. The dark green bots are doing bin put away. The yellow bots are digging. So as I said, when you're digging for a tote, you might send multiple bots, or a bot does multiple shifts to get at a bin that it needs to get to. I'm going to ask to play this video now. And you see the bots moving around, which is pretty cool. And then something crazy is going to happen. This happens, which looks insane, really. What this is doing is showing you the planning system. The planning system operates in real time, and the X and Y axis is the bot's movements, but the Z axis is time. And what it's showing you is that the system is anticipating where the bots need to go. And if you can pause it right there, please. Thank you. So if you think about, I'll give you an example. The yellow stack on the left, there's a big stack of yellow. So what the planning system is doing is saying, I need the 5th bin below that top of the stack. I'm sending 5 bots to that, and I'm stacking, well, it's showing the time scale as time moves into the future, what I'm planning to do, which is remove that bin, remove the next bin, the next bin. Ultimately, the last bin becomes green, and you can see the path that the system has chosen for it to move once it's picked that bin. If you can continue playing, that would be great. There are 3 major problems that we need to solve when looking at a system like this. The first problem is, where do you put the stuff? In our big warehouse near London, there are 750,000 bin locations and 50,000 unique SKUs. So where you put them is quite a difficult algorithm to try and figure out. The second issue is, what do you do next? Like, you've got bots that are just doing things. Do you put things away? Do you go to the inbound? Do you recalculate the hive? So there's intelligence that needs to be analyzed and put into there to ensure it's in the right location. Just while I'm talking, this is showing the pick station. So the green bins on the left are the inventories that come through. People are standing there, picking from that, and putting it into the customer totes in the red. The difference between this and the previous system, obviously, is that everything here is goods to man. So the efficiency that you get by doing that is very high. And also, when you have the ability to focus where everything happens, the ability to automate that process is really high as well. The third issue in trying to determine how to make this work is basically, how do you stop the bots from running into each other? The difference in grocery versus ambient or general merchandise is that the pick cost has to be very low for grocery because each individual item is very, very cheap. So you have to have these bots moving very quickly, accelerating quickly, so that you're minimizing the bot time. And that's the currency that we analyze for and try and minimize, is when we're planning this, how do we use the least amount of time of the bots to get the required amount of throughput from the warehouse. So here's a little video that shows some additional simulation. Oh, there's video, there's audio. I didn't know that. Sorry. You don't listen to her, just listen to me. So there's 2 things that happen in the planning system. One is that there's a high-level planning system that says, go from here to there and get that bin. Now, that's fine, but when you have, in Erith, our large warehouse, there'll be 3,000 bots on that grid. The problem is that these are physical objects, and the wheels will slip, or there'll be slight timing miscalculations, and you'll have to recalculate everything to ensure that there's no collisions. So we have a low-level planning system, a clearance system that you see here. So that basically says, for the next 4 cells, can I move? And if so, I'm going to move there. Before I get to the end of that path, I'm going to ask the clearance system, can I keep going? So this is what the low-level clearance system looks like, rather than the big planning system, which we saw in the earlier video. And this is what it looks like in real life, in operation. This is this was our warehouse in Andover, which some of you might know burned down a couple months ago. We won't talk about that in any great detail. But this is the bots, and you can see, as you've seen probably in videos like this, there's very little tolerance for mistakes here. The gap width between those bots is 5 millimeters, and they travel at 4 meters per second. So they are precision equipment. Which kind of brings me to the first slide about AI, because this is supposed to be about AI. Our systems are built on computer science knowledge, not machine learning. So these are algorithms built on A-star path search with some tweaks, as well as a lot of put-away algorithms to make it efficient. So it might surprise people that we're not using machine learning. This might still be AI, depending on your definition. Like, think about the ants. It looks like AI, but it's probably not what you think of AI, i.e. because it hasn't been done yet, and this is obviously operating. But I'm going to talk 2 seconds about a neural net. Like, it is just a statistical model. And so you look at this and think you have lots of data. You could actually build a model, and you can test it, because we do all this statistical analysis. We could quite easily evaluate it. The problem is, how do you evaluate whether the AI system is doing better or worse? If you think about a chess match, it's 40 moves for an average chess match versus 750,000 bin locations, 50,000 items, 300,000 orders per week. Like, it's just an order of magnitude, many orders of magnitude much bigger. So the question is, a minuscule decision, i.e., I put the bananas there instead of over here, how do you figure out whether that decision has made the system more efficient? That's really the problem in terms of using the machine learning. It's really difficult to train. And it's also competing with really robust path search algorithms. So even with all the efficiency we have, there's still lots to do. And so the last thought I'll leave you with is, I'm not sure if what we do is AI. I'll leave that for you, but it looks pretty clever when you see it. Thank you very much.
Stuart, that was superb. Right, I now want to introduce our panel. So Sonia Dowsett will be our moderator, and she will introduce the 3 presenters and panelists shortly. Sonia.
Well, we have a great panel now this afternoon, wide range. We've got Akash from GreyOrange, who started off as a young student in India playing around with robots, and now spends his life traveling around the globe with different clients from Sweden to Singapore, and recently launched in the US, helping clients and tinkering with the systems to make sure they're going well and seeing how he can adapt them. We've got Kenneth Cassar from, I've pronounced your name wrong, haven't I? Despite all the practice. From Rakuten Intelligence, who'll be able to give us some of his expertise gleaned from providing intelligence in the US to investors and retailers and brands about how to get the best out of their e-commerce strategies. And then we have James at the end here, who's with C-Commerce. And this is a really interesting, C-Discount, a really interesting real-life examples of how actual real-life companies are implementing these systems, these robotic systems. So thank you very much indeed. Akash, can we start with you, with your presentation?
The click. Hi, my name is Akash Gupta. I'm one of the co-founders and CTO at GreyOrange. So what we have seen in last 10 to 15 years is that there's been a large change in the overall consumer behaviors, their purchasing behaviors, their expectations. We have seen lately that there's been more and more people buying online, right? And as people are buying more and more online, they're also still buying through retail stores. So the experience for a seamless experience across channels is something that is a new expectations from most of our clients and consumers. What we've also seen is that there is much higher service expectations, right? It started with 2-day, 3-day deliveries, and went to next-day deliveries, AM, PM deliveries came in, and today, same-day deliveries has become that everybody is trying to get to. One more macro change that we have seen, in the overall, I would say, consumer to manufacturer, transaction is that things have been more personalized. The number of SKUs that used to be there have exploded multi-times. So at some point of time when Apple had 2 or 3 phones, now they have 6 types of phones, different memories, different colors, and things like that. So what it has led to is that it has led to a rise of, I would say, omnichannel shopper who wants to shop through multiple channels, needs a lot more higher service expectations, more personalized goods. What we have seen in last, I would say, 30 to 40 years is something we call as rigid automation. Rigid automation started with, with manufacturing centers, factories, where it was originated, then moved on to the warehouses. What rigid automation was, pretty much the requirements was fixed, the type of SKUs that were handled was fixed. We were handling pallets or cases, and was very, very inflexible. What it has to become for the needs of supply chain is a lot more flexible automation. It has to adapt to things. It has to adapt to SKUs growing in the warehouse, the demands of consumers growing in the warehouse, the speed of delivery changing in the warehouse. So what GreyOrange has done is to come up with, I would say, a set of standard hardware. That would be controlled by a very, very intelligent software that can learn the characteristics of the warehouse, that can understand different challenges of the warehouse, be flexible, and drive these set of hardwares to fulfill different needs of the fulfillment centers. So GreyOrange wants to enable world's most flexible and automated warehouses. And let me kind of take you through how that would look like. There's no sound. So today we are present in, I would say, multiple geographies with 2 R&D centers and 70 plus customers all across the world. Thank you.
Thanks. Kenneth.
Right, hi, I'm Ken. And I'm from Rakuten Intelligence. Instead of spending time talking about how we do what we do, just trust we're a market research company, and you're probably more interested in seeing what we do with what we do. This is we're tracking US e-commerce, and in this particular chart, we're tracking how quickly packages are delivered to consumers. In the US, generally speaking, the way e-commerce works is that goods are shipped to consumers over thousands of miles via third-party shippers, and it tends to take a while for packages to get to consumers. It's been getting quicker and quicker over the course of time. This is click to door, so that's the interval between when the consumer consumer places an order and when that order arrives on their doorstep, we can see that it's improved by nearly a day just over the past year. But one thing that we see is that there's a dramatic difference between different retailers. Some retailers are much faster than others. The most notable difference is between Amazon and all others. We can see that Amazon is still 100% faster than its competitors. We can also see that both Amazon competitors as well as Amazon are getting faster and faster over the course of time. What's interesting is if we decompose, here we're looking at Amazon, we're decomposing that click to door into the interval between when we place our order and when the order leaves the warehouse and then when it arrives on the doorstep. And as we can see, over the course of time, Amazon has been improving on both of those dimensions. 0.2 day improvement just on the fulfillment center turnaround speed, 0.3 days on the delivery speed. So they're improving on both dimensions. When we look, and obviously, this has been an expensive endeavor for Amazon. $34 billion in spending on fulfillment globally, increased by 35% just last year. And when we compare that to the rest of the retail landscape, we see that that the rest of the retailers are improving their fulfillment speed in a very different way. For the most part, that 1.2 day improvement we saw from retailers not named Amazon has come from faster deliveries, which tend to be very, very expensive. And other retailers in the US, Amazon has about 40% market share. Other retailers don't have the scale. They can't make those sorts of investments. One of the ways that retailers have been getting around that is by working with third-party logistics companies. Rakuten Super Logistics, which is a sister company of ours, has actually engaged in kind of an interesting model with a company called Invia Robotics, where they're trying to take kind of the on-demand model to robotics. So you pay as you need it. And so the combination of a third-party vendor with the robotics as you need it model is kind of an interesting way of kind of managing that risk. The other big thing that we've been seeing in the US lately is the growing importance of local inventory. So rather than inventory being shipped across the country via a third-party shipper, we're seeing more and more inventory emanating locally. And this is taking a few different forms, most prominently click and carry. Buy online, pick up in store, click and collect. I think we all have different terms for it. But when we look at the combination of the 10 biggest brick and mortar retailers that sell online in the US, if we go back 4 years, we can see that about 18% of online sales volume for those retailers was click and collect. That's up to about 38% year to date now. So more and more volume is coming through there. And obviously, click and collect inventory is largely going to be sourced from local stores. The other model that we've been seeing more and more of in the US is ship from store. Target has been where items are shipped from stores rather than from warehouses. Target, as they've moved toward a ship from store model, they used to ship packages an average of 800 miles. Now they're shipping packages an average of 300 miles, and it's getting shorter and shorter. Obviously, that increases speed. It improves cost. The other thing that I didn't create a slide to talk about would be same-day delivery, which is obviously another important element of local inventory. Same-day, it has been growing very, very quickly. When we look at the aggregation of the biggest vendors, they're growing by more than 100%. That would be Prime Now, and others that slip my mind right now. But collectively, they account for less than 2% of total volume in the US. So there's a lot of growth. We talk about it a lot, but there's not as much activity as we might think. And finally, I think in this kind of dovetails with what we're talking about today, which is kind of that hybrid where we have localized inventory and automation, but we're starting to see it being pushed locally. So rather than this highly automated warehouse that might be far away from us, it's getting closer and closer and smaller. This particular model, this is Takeoff Technologies working with a grocery retailer in the US called Stop and Shop. It's got a small footprint, few employees, employees, but it is 10 times as productive as a pick-from-store model. And with that, I will pass the baton to our next.
Ken.
Hi everyone, I'm James from Cdiscount, and I'm going to show you how we warehouse automated our logistics. To begin with, Cdiscount is an e-commerce French leader with 20 million of unique visitors per month. GMV amounted to 3.6 billion euros in 2018. Cdiscount was created 20 years ago as a seller of products. Now, and over this period, Cdiscount has been building an IT platform able to connect millions of clients with tens of thousands of sellers and partners. Now, Cdiscount has 50 million products in its assortments and provides services such as ticketing or, for instance, energy provider for your house. Last year, we shipped 20 million parcels from our warehouses, which are located all over in 3 main areas, so Bordeaux, Saint-Etienne, and Paris. And we have 500,000 square meters of warehousing surfaces. From these surfaces, we can cover all the national territory and 20 countries within Europe. With our really extensive network of shippers and click and collect points, we are able to deliver really fastly, flexibly, and with high quality. We notably deliver same day in the 6 main cities in France. To do so, we have to open innovate. We have to be on the fringe. So we decided 3 years ago to launch an open innovation program where we build an ecosystem sharing the different capabilities and skills of all the different actors. The know-how, the expertise, and the agility of startups, for instance. We have a complete set of tools to accompany the different actors. To start with, we have long-term partnerships with big companies, large companies, and we share R&D. Then, dedicated to accelerating the road to market of some startups, we have an accelerating, so an incubator dedicated to accelerate the road to market of 5 startups a year in order to transform and convert the concept or prototype into a product. We had last year a 60% success rate. Then we have a short-term approach, less than 6 months. We can test easily solutions which are ready to use and which are off-the-shelf solutions. And we more or less test 15 proof of concept a year. This is a good way to test and innovate really fastly with our complete ecosystem. I would like to share with you different solutions. The first one would be the genesis of our warehousing and incubator program, which is the Exotech solution. Then the first success of our first batch of startup of the accelerator program, which is NoMagic, and then we will conclude with the CVP machine. Normally, it should start the video with the sound.
is an autonomous, high-performance order preparation robot. It can move 30-kilogram bins anywhere within the storage thanks to its laser scanner navigation. And it actually moves in 3 dimensions. The system handles all the goods in a mass storage. As soon as an order takes place on the internet, the system controls sends robots at a speed of 4 meters per second to pick up the
Now, the second video, may you start it, please? Here's No Magic. I told you it was the first success of our first batch of our accelerating program. This is a mechanic and robotic arm dedicated to pick, place, identify products, and to put it into parcels. It is hardware combined with software with artificial intelligence to be able to detect precisely the product and to apply the good velocity and speed to scan the product. And the last one, may you start the video, please, is the CVP. So this machine has been co-designed in our POC factory program and reduces the vacuum in our parcels by 30% and reduces the consumption of raw material by 30% too. Thank you for your attention.
Well, thank you very much indeed. 3 very interesting presentations. Let's turn now to looking at difficulties that companies might have implementing these systems and challenges when it comes to implementing them. Akash, can you talk about some of your clients, the difficulties that they come across?
Sure. I think I would say one of the most difficult thing is to change the operational mindset. I would say, right? There are people or operators who are running warehouses for 20, 30 years, and when you bring in automation, the biggest challenge is to kind of educate them in order to how to now run their operations with the new strategy or the new fulfillment strategy you will have to adopt. So I think changing the mindset of operations is one of the biggest challenges.
And is that something that the retailer or the warehouse operator has got to take care of before the robots are brought in?
No, absolutely. I think as we do today is as soon as the deployment starts, there's a separate team that starts engaging with operations, and trying to kind of evolve their operational strategy, because again, it's not magic, right? Finally, even if you put robots and everything, there has to be a operational strategy to kind of execute that. So we have a separate team that would engage with the operations team while the installation is happening to kind of redefine this strategy in terms of how the overall warehouse is going to run from morning to evening with the new fulfillment strategy.
But once that step is done properly, there's usually no problems, is there?
Yeah, so I think we have for the clients who have adopted the right strategy, we have seen huge gains in terms of and very, very smooth deployments as well after that.
In a short period of time?
I think normally it would be 2 months to 3 months where you would kind of get used to it, and then things become really, really smooth.
So, I mean, this is no longer becoming an option for big retailers. Ken, what in the US, from your expertise from the US, what have you seen there about big retailers making these investments?
Yeah, the biggest challenges that big retailers have had in the US has been trying to figure out how to use their stores. Which historically have been a bit of an albatross, a bit of a problem for them in terms of their e-commerce strategies, but figuring out how to use those to their advantage. One of the reasons probably the big reason that Amazon bought Whole Foods was because it didn't have stores. It needed to compensate for that. If we look at stores like retailers like Target and Walmart, they have a lot of stores, but they haven't historically been able to take advantage of those because
they take advantage of the space.
Yeah, the space and the proximity of stores. Mm-hmm. And what they've had to do is think about their stores differently. Instead of in the earliest versions of where retailers were using stores, they had people walking through the stores, picking items, and we still see that very, very predominantly in the U.S. But increasingly, we're seeing retailers realize that they need to do things differently. In Walmart and Target, for example, are both taking inventory with robots in stores. Right now, that's a test so that they have reliable inventory that they can take advantage of for click and carry or store-based delivery. We're hearing about drones for inventory taking. And then we're also seeing retailers carve out space. So if they have 100 square feet, instead of using 80,000 of those square feet for selling 20,000 for back room, they're expanding the back room space in order to build out these sort of automated fulfillment centers so that they can more efficiently pick and pack those orders. But I would say that they're still baby steps. We haven't fundamentally reimagined what the store looks like in the U.S. We've sort of nipped at the edges. So there's still a lot of room for growth.
Mm-hmm. James, there's some very interesting examples there that you showed us of how Cdiscount was actually working alongside startups and kind of flexibly using them to your own needs. So you're actually picking out startups and you're on a journey together to get the right product. Can you talk a little bit about that and how collaboration has played a role?
Yeah. In fact, as a retailer, as one of the leaders in this context, we assume and we are convinced that we have to shape the products and services of the future. We don't have the expertise, the agility, the know-how to do so, to build the products and services. But we have the playground, we have the expertise, the know-how, and the flows and the volumes. So we decided to start this open innovation program 3 years ago after having the first success with Exotech. Exotech came to us in 2016 with a PowerPoint showing us a way to do a 3 dimensions picking system in our houses.
And this is a startup,
And this is
right?
the start.
This is the startup.
This is the start with a PowerPoint. Mm-hmm. And we decided after 2 or 3 meetings to go further with them. 1 year after, we had the first system that you've seen on the movie in our warehouses. So this first system was 2,000 bins with 10 robots. Now we've been developing the new system in one of our warehouses in the suburbs of Paris, in Réau, where we have 50,000 bins with 50 robots on 3,000 square meters. So we are getting further and further with each startup we are accelerating. The success rate in 2018 of 60% is representative of our mindset. We are really implied in this kind of scenarios. And we are focusing on the 2019 batch on 3 robotic solutions, 1 on blockchain and 1 on the last mile delivery. So we decided to build this full ecosystem dedicated to startups, to large companies, to laboratories, to other big companies, to share with them and to build the product of the future. We have been electing and selecting the good issues to be covered by our innovative approach. So we have 4 main priorities. The first one is to reduce the work penability, the work arduousness. The second one is to optimize the customer experience. The third one is to optimize the performance in terms of costs, in terms of productivity or density of storage. And the last one is to deploy a corporate social responsibility approach in terms of ethical issues and in terms of ecological footprint.
So James is talking there about Akash. Could you, how Cdiscount has worked alongside these startups? Mm-hmm. Is that something, you actually make these machines. Is it an ongoing process? It's not a case of just showing up with the product. You have to work right from the start, find out what the retailers or the client's needs are, and produce a bespoke product and system for each client.
No, absolutely. I think it's a journey. It's a journey to understand the customer needs. You would always come up with one of your versions that you would deploy, but after that, it's a journey to understand different industries, to make sure that you have a product that could go into any different warehouses. And again, I think we have always been fascinated how different each warehouse was, when we visited different warehouses, and we always wanted to kind of build products that can be deployed all across different warehouses without a lot of customizations. I think we have been always thinking as warehouse as a product, then deploying multiple kind of customizations. And for that, it's a ever learning journey to kind of understand the customer needs and making sure that with large part of, I would say, algorithms and AI, you can make sure it adapts to different needs of the warehouses and keeps learning.
So I think you were saying earlier that your products just run on one code, and you've implemented, they're self-learning. So they actually adapt themselves.
That's correct. So most of our core product is single core product that runs across all the 70 sites we have. And it keeps on understanding the inventory characteristics, order characteristics, even small changes, peaks and things like that. And it evolves accordingly. Different algorithms are built in a way that it can understand most of these and evolve, suggest operators to kind of run the operations in a certain way. So yeah, I think that's been one of our core strengths.
You were talking there, Ken, about Amazon, Walmart, Target. These are big companies with big war chests of cash. Are these systems prohibitively expensive to implement for your mid-size retailer?
Yeah, small to mid-sized retailers are, I think, are generally challenged. And in the U.S., we have a robust third-party logistics infrastructure that is there to provide services to retailers that can't compete on that dimension. Generally speaking, we tell retailers that unless you're at that level of scale, you have to work with partners. And another key part is you've got to understand where you want to differentiate. Differentiation based upon product is probably a critical for a lot of retailers that don't have that level of infrastructure that allow them to deliver next day. And so it really is a matter of defining your differentiating edge on a basis that you can actually compete when you're smaller. And of course, folks like Amazon are opening their systems up to others as well. Amazon has evolved from a business that was probably 95% first party, 3% or 5% third party, to now about 60% third party. It really has become a third party logistics company that happens to also sell some stuff directly. Interesting.
And Akash was talking about, kickback from maybe workers within the warehouse and the importance of getting those people on board and working alongside machines. Are you finding, James, you're coming from the coalface there of implementing this technology. Are you finding that it's freeing up your workers to spend more customer-facing time?
In fact, we, in this approach, we start with the concerned operator to think about the future solution. So we ask the operator to be there at the first meeting and to share his vision with us. So he co-designs, he co-implements, and he co-deploys all the solution with us.
So this is the person who was doing the job before the robot came along?
From the beginning, the operator in our warehouses that is going to use the solution to co-robot with the solution is from the beginning with the full team project to build the future solution. Because he wants to reduce the repetitiveness of his work. He wants to improve the workstation ergonomics, and he wants to kill many pains of his daily jobs. Secondly, we speak more about cobots more than robots, because we are really convinced that we have to combine and to mix the different skills and capabilities of robots and humans. For instance, a robot, main skill are repetitiveness, strength, and precision, while main skills of a human are know-how, the ability to make decision, or the analysis of a solution. All in all, every automation that we've made in our warehouses was made in order to serve the growth rate of our really fastly growing market. For instance, in 2016, we only had 70,000 SKUs in our warehouses that we were storing. Now we have 300,000 SKUs in our warehouses. And we were able to do that by mixing and combining the different skills of operators and human and robots. For instance, with Exotech, we were able to multiply by 5 the productivity. So we started from 80 operations per hour to 400 operations per hour. In terms of density of storage, we were able to store until 2 meters dedicated to picking, and with this kind of solution, we can raise up to 10 meters, so we multiply by 5. All in all, reducing the work penability, the work repetitiveness of the work of the operator. To conclude on this precise question, when we started with Exotech, the pain point was that an operator was walking 15 kilometers a day in our warehouses. With this solution, it reduces until 1 kilometer a day.
That's a great reduction. Akash, give us a little peek then into the future. What are you working on now? What are we going to see in the next 5 years? We've seen this huge change over the last 5 years. What are we going to see?
Yeah, so I think we are pretty much working to make warehouses as flexible as possible. I think with changing needs, and you mentioned that he grew from 70,000 SKUs to 300,000 SKUs. So today that's a nightmare for any warehouse handling person. How would you include different categories? Fashion has moved from 4 seasons to 12 seasons, and whatnot would happen in 5 years. So I think we are fairly focused to make sure that we provide the flexibility in the warehouses with the right automation and with the right software platforms for our customers.
Well, thank you very much indeed. A big round of applause, please, to our wonderful panel.
Excellent. Well done. Excellent panel. Really interesting. Well done. So that's the end of the formal aspects of day one. So very shortly, you'll exit this room. There's a drinks reception, food available. There'll be guys to take you across there. I've just got a bit of housekeeping before we leave. Those that are going on coaches to your hotels, can you make sure you pick your bags, your overnight bags, and take them to the hotel with you later on? Yeah. Now the coaches will be leaving from outside here between 10:30 and midnight. Now, if you want to go earlier, then come and get your bag and make your own way, I guess. But 10:30 to midnight, don't leave your bags, because your bags will then be here and you won't have anything to change in, and that'll be very unpleasant for everybody, particularly the person sat next to you tomorrow. So don't do that. Okay, tomorrow, really important this. All the buses will be leaving your hotels at 8 a.m. sharp, because we've got a tight schedule tomorrow. So you can start boarding at 7:45. So in your hotel, get to reception by 7:45, and then you can board your bus from there. Final thing, the awards, which I talked about first thing this morning. Retailers, this is your opportunity to appreciate the stars in the industry. So you need to go to app.deliver.events and vote. That would be awesome. The bar is now open. Leave through the exits, and I'll see you over there. Thank you.